The activity used in this video came from the Futures channel. The investigation setup is shown here. We attach two rulers to a desk and attach a cup to the bottom ruler. Pennies are added to the cup and the amount of bend is measured. After Mike plots the data on a graph, I ask the following question. What if I asked you to
ratio, I guess,
estimate it at 2,000 pennies? Or even 300 pennies?
I'd probably do a ratio, I would think.
A ratio? Explain.
Like, if your graph's always consistent, you're going to come up with the same change every time.
Okay.
So if you have 20 and you have a change of 2.5, so 2.5 over 20 equals, let's say you're trying to find 2,000. 2.5 over 20 is equal to 1 over 2,000 because it's the same.
Okay.
See what I'm saying?
Right. Okay. Go ahead and use the paper under your scratch paper there and work it out for, say, 300.
300?
Yeah.
Let's see. We'll just go with 40.
So you have n over 300 and 3.5 over 40. Why'd you pick 3.5 over 40?
Or 5? You mean 5.3?
Oh, 5.3 over 40. Sorry.
Because that was my measurement for that amount.
Okay. Oh, at 40, and you're at 5.3. Okay. And you got 39.75. Okay.
That's pretty good, actually.
This is interesting. What's this? Divide this out with your calculator. What do you get?
0.096 repeating.
Okay. So what do you get if you divide this out?
What, 7.2 over 60? Oh, wow. That's quite odd. Well, I thought it was amazing how my ratio thinking was pretty much the same as my slope.
Yeah.
And didn't even realize that.
That's right. That's right.
That's
good.
That's pretty. I never even would have thought that would be. I've never heard of anything like that, honestly.
I taught this lesson a second time with Michelle. It progressed quite a bit differently, in part because I started differently. Rather than asking Michelle to record the data directly on a graph, like I did with Mike, I let her decide how to keep track of the data. She chose a table, which she used in the next clip to estimate the amount of bend at 130 pennies.
Multiplying by 2 after you find average or something?
Explain.
Well, 65 is half of 130. So you'd find 65 and then multiply it by 2.
Oh, well, let's try that. That's interesting.
After plotting the data on a graph, Michelle was surprised about how straight the line was.
Graph. Wow, that's cool.
What's cool?
It's like a perfect line.
Pretty close, isn't it?
Yeah. You drew the line there pretty perfect.
Did that surprise you?
Yeah, because when I was doing this, it didn't look like it was the same amount.
I've decided that the most significant thing about this project was how much the students enjoyed it. Here's what Michelle said at the end of the lesson.
So how did you like this activity compared to what you do in school?
I liked it because I actually like using this. Like in physics, we just use, force. Well, it's kind of like this, but it's more like my science classes to me. Because in math, we don't do this stuff.
No.
We do this. We don't do this.
And you like this part?
Mm-hmm. It's more fun when you get to see it.
Neither of these students particularly liked math. In fact, both quit taking math as soon as they had met their high school graduation requirements. However, both students liked this lesson, and it is this aspect of this lesson which I think is most valuable.